Okay, here's our topic. All right. We want to be able to, you're trying to predict an unknown's identity, but talk about like use PE, how they're connected. All right. Here's a QR code for the notes in the slides. Here's our objective. All right. And these percent error values are usually going to come from a standard that you've done to like ensure you're getting good data or not. I'm going to give you an analogy of what the objective means. Let's say someone went to buy a car, and they have an option between two cars. When they go to think about their decision, they're going to think about maybe some advice that they've gotten about the cars from someone. They might think of something else, some other things that they're going to weigh their decision upon, and then they're going to make a choice. All right. So they went with the bad engine car. Now you could think of it like Larry. He's got this advice and he's making a decision. And in this video, you're going to have percent error is going to give you advice, and you're going to use that to decide about an object's identity based upon some data on it. So for you could think you could think of these 3% error values for like in three categories. One being low, or very low. Like when you're measuring a standard, same way that you're measuring your unknown, and you're getting really good values. What that means is you can really trust your data, and the value of the unknown should match like the value accepted of a known quantity. And if your percent errors are not a little bit, around 10%, let's say, there's a bit of a grayness to it. You're usually going to get more data. If you're getting really high percent error values, then really your unknown could be anything. Excuse me. So let's go over some examples. Okay, this person wants to know what the liquid is. They measure its boiling point. They do it 3 times. You can see all those numbers are around like 78 ESC, 77.5 ESC. They do the percent errors, or they do the experiment with a different liquid, a standard liquid, the liquid they know the identity, and they get here their percent error values. These are pretty low. This is good. Means it's an average of about, let's say, 4-ish. So that means these numbers here, the 79 of the unknown, those are close to the actual. You can predict they're close to the actual values. Then they look up values accepted of various liquids, and they come up with these 3. You can see that this is very close to both of these numbers. Therefore, you can eliminate gasoline, but you can't discern between these two, but you can say it's maybe either of them. All right, which is good because now you can do another test for that, for which one of those it is. Okay, here's a different set of data, similar idea. They're measuring density, and they got these 3 numbers. That's about average of about like 8.2 or so, and they've got moderate percent error values. All right, then they compare it to values accepted. Well, these values are the unknown values are very far away from aluminum's density, so you can eliminate aluminum. They're pretty far away from silver, and with your percent error values being what they are, you can kind of eliminate it, and then you find iron, and that's irons. You can kind of say, yes, it could be iron, but we want more data to confirm. All right, we don't like these kind of high percent error values, so you'd want to be like tentative about any conclusion you would make upon that. Now, one final thing. Let's say you're doing a liquid again, and you've got all these boiling points. That's like 90, right around 99. Water, could it be water? That's very close. All right. Ethanol, it's far away, and rubbing alcohol, it's far away. But then when you look at the person's percent error value, no, that's why water's there. You're like, hell, it's got to be water because they're close. But then when you look at the percent error values, they're way big. Therefore, you can't trust the closest of the unknown's value to the value accepted. Therefore, you're like, I have no idea what it is. All right. Hope this has been helpful, and have a good day.